All right, so if you've ever been curious about building out your own ML infrastructure, well, you've come to the right place.
Definitely.
Because today we are taking a deep dive into Lambda Labs ML Infrastructure Playbook by Stephen Balaban.
Yeah.
And this playbook is like your roadmap from a single workstation setup
Yeah.
all the way to like a full-blown data center.
It really is.
And we've got some fascinating data from their 2021 AI survey that I think will really make you kind of rethink the ML landscape.
What I think is really cool about this playbook is that, like, Lambda Labs doesn't sugarcoat it, right? Like,
Yeah.
it's not all massive GPU clusters and, like, these billion-dollar budgets,
Yeah.
right? Like, it's really...
Yeah, I was surprised to see how much emphasis they put on, like
Yeah.
starting small.
Totally.
You know, you'd think with all the hype around like these huge language models, everyone would be scrambling for the most powerful hardware.
Well, and their AI survey really paints a different picture, right? Because it turns out that both GPU access and R&D team size in the ML world, they follow what's called a power law distribution.
Okay, power law distribution sounds a little intimidating.
It's not as bad as it sounds.
Can you break that down for me?
Yeah, so imagine you have like a graph of GPU access in the ML world, right?
Okay.
And it's not going to be this like nice even curve, right? What you're going to see is like this steep drop off, right?
Yeah.
Where it's like a few giants hoarding most of the GPUs and then the rest of us.
Right.
Right. It's kind of like the 80-20 rule, but even more extreme.
So even with models like ChatGPT making headlines, like most of us are still working with like limited resources.
Yeah, exactly.
That's actually kind of reassuring.
Yeah, totally. You don't need a supercomputer to get started with ML.
Right.
And you can achieve a lot with a single workstation, especially when you really understand how to optimize it.
So let me get this straight. Like the majority of ML work is still happening on single workstations.
It is.
That's pretty mind-blowing considering like all the advancements we're seeing.
It is.
But the stuff that's coming out, yeah.
And it really highlights like the accessibility of this field, right? Like you can dive in and start experimenting without needing this like massive budget or infrastructure.
Yeah.
Right. And the playbook actually emphasizes that starting with a single workstation is really the recommended approach for most ML engineers and researchers.
That makes sense.
Yeah.
So where do we go from there? Like at what point do we need to start thinking about scaling up?
Well, as your projects grow and your team expands, you're inevitably going to face this age-old question.
Yeah.
Cloud or on-prem.
Right, that classic dilemma. It's
Yeah.
like choosing between like renting a fancy apartment or like building your own house.
Yeah.
Both have their like perks and drawbacks.
Totally. And the playbook does a great job of like laying out the considerations for each option. So think of the cloud, right, as renting a powerful computer on demand.
Okay.
Right. You get flexibility, scalability. This is really great for things like production inference or, you know, when you have those unpredictable spikes in your workload.
So the cloud is kind of like that friend who always has the latest gadgets, but maybe isn't the most reliable in the long run.
Yeah, I mean, there's some truth to that.
Yeah.
Right? Like cloud costs can add up quickly, especially for those really, really long, intensive training jobs. And, you know, some organizations have concerns about data security and privacy when they're sending their data to the cloud.
Yeah, that makes sense.
Yeah.
So when would going on-premise be the better option? Is it all about like cost savings?
Cost can definitely be a factor, especially if you have really consistent, heavy compute needs.
Right.
And Lambda Labs points out that on-prem can be a much better choice when you're dealing with like massive data sets and like you have these really expensive data egress fees, right? It's like building your own custom PC, right? You have more control,
Right.
but it requires that upfront investment
Yeah.
and the know-how to actually manage your own servers.
So there's no like one size fits all answer.
Yeah.
It's all about like weighing the pros and cons based on your
Totally.
needs and resources.
Yep.
But here's what really surprised me.
Okay.
You remember that Lambda AI survey we talked about?
You mean the one that revealed that over 40% of respondents still train their models on-prem?
Exactly.
Yeah.
It seems like there's still a strong preference for like owning your own hardware.
It's an interesting trend.
Yeah.
And it really highlights the importance of like carefully evaluating your options.
Yeah.
Right. And the playbook's a great resource for that,
Okay.
especially when it comes to understanding the nuances of each approach. regardless of whether you go cloud or on-prem, they
Yeah.
recommend starting with that single workstation setup
Right.
we talked about.
Okay.
It's the most efficient way to get started.
Thanks.
It lets you iterate quickly without breaking the bank.
So how do we go about like picking the right workstation for the job? Are we just looking at like raw specs, or is there something else we should consider?
That's where GPU benchmarks become your best friend.
Okay.
Right. Think of them as a head-to-head comparison of different GPUs running specific ML models.
Okay.
Lambda Labs actually has their own benchmark database,
Oh, cool.
along with resources like MLPerf that can really guide your decision-making.
Okay, so instead of just like blindly picking a GPU based on specs
Yeah.
alone, we're actually looking at like real-world performance data
Real-world performance data
that are specific use case.
for your use case.
Yeah,
Yep,
that's smart.
exactly. And let's say, you're training a ResNet 50 model, right, for image classification.
Okay.
You could find benchmark data showing that one particular GPU delivers like a 3x speed up compared to another on that specific task,
Oh, wow.
right? And that kind of information can be incredibly valuable.
So we're not just throwing darts at a board here.
No.
There's a real science to it.
There's a science.
It's using the right hardware.
Absolutely. And as your team grows, right, and you start sharing resources, Lambda Labs has a really clever trick up their sleeve.
Okay.
The See to Visible Devices hack.
Now, who doesn't love a good hack?
I know.
Tell me more.
So imagine you have like an 8 GPU server,
Okay.
and you've got, 2 team members,
Okay.
Joe and Francie, right?
Right.
This command lets you assign specific GPUs to each user,
Oh.
right? So you could limit Joe
Right.
to using only GPUs 0 and 1, while Francie gets the rest.
Gotcha.
Right. It's a really simple way to prevent resource conflicts without needing a complex job scheduler.
So it's like creating like these virtual compartments
Yeah.
within the server to make sure that
Even-
everyone has
sure.
their own dedicated resources.
Exactly. And they even provide a way to set this up permanently in each user's profile,
Oh, that's great.
so they don't have to type in the command every time.
Yeah, that's super handy.
Yeah.
But I can imagine this getting a little messy as the team grows and the projects become more complex.
Sure.
Like, at what point do we need to consider like a more robust solution?
Yeah.
Like a job scheduler?
That's a great question, and it leads us to the next stage in our ML infrastructure journey. Think of a job scheduler as a traffic cop for your compute resources,
Okay.
right? So it's directing the flow of all this data
Yeah.
between all these servers and GPUs.
Yeah. Yeah.
As your team grows and more jobs are submitted, the scheduler makes sure that everything runs smoothly
Gotcha.
and efficiently.
Okay, so I'm starting to see how a job scheduler becomes essential as we like really start to scale up.
Oh.
What are some of the like popular options out there?
2 names you'll hear a lot are SLURM and Kubeflow,
Okay.
right? They're both really powerful tools that can handle that complex orchestration of resources in a large-scale ML environment. But for smaller teams just starting out, Lambda Labs actually suggested a different approach. Lambda Stack.
Lambda Stack.
Yeah.
Is that like a pre-built software environment, like specifically for deep learning?
You got it.
Okay.
Think of it as a one-stop shop
Okay.
for all your deep learning software
Yeah.
needs.
Uh-huh.
It comes pre-installed with all the popular frameworks and libraries. It's managed and updated automatically,
Nice.
and it provides a really consistent environment across different hardware platforms.
That sounds incredibly convenient. It's like having like a personal chef
I like that.
who prepares all your favorite dishes without you having to lift a finger.
That's a great analogy.
Yeah.
And the best part is it's incredibly easy to set up.
Okay.
Literally takes a single command to install.
Wow.
They really pride themselves on simplicity.
So it's perfect for like those smaller teams who want to hit the ground running
Totally.
without getting bogged down in like complicated setup processes. But what about like larger teams who need more like customization and flexibility?
Yeah.
Do they just like ditch Lambda Stack altogether?
Not necessarily.
Okay.
They suggest combining Lambda Stack with the NVIDIA Container Toolkit and Docker and GC containers
Okay.
for those larger teams.
Yeah.
This gives you the best of both worlds.
Yeah.
Right? You can create and manage your own custom software environments,
Right.
but you still benefit from that pre-configured base of Lambda Stack.
Okay, so it's like having like a base camp setup for you,
Yeah.
but you're free to like explore and
Yeah.
build your own like customize shelters from there.
Like that.
And speaking of building, I know we're moving beyond those single workstations now.
Yeah.
Things must get really interesting when we start talking about building like actual clusters of servers.
It does.
What are some of the like key considerations at that stage?
Well, the first thing that jumps out is networking,
Okay.
right? As your cluster grows, the network becomes like the central nervous system, connecting all those servers and GPUs.
Right.
And they kind of outline a typical progression you might see as your cluster expands.
Okay. Walk me through that progression. Like
Yeah.
what kind of network speeds are we talking about here?
So you might start with standard 1 Gbps Ethernet,
Okay.
right? Which is like, a single lane road for data.
Gotcha.
But as your cluster grows and the demands increase, you'll need to upgrade to something faster, right? Think 10 GBPs, then 100 GBPs, and for those truly massive data-hungry clusters, you might even venture into the realm of 200 GBPs InfiniBand.
Wow, 200 GBPs. That's like a super highway for data.
It is.
What's so special about InfiniBand, and why is like that high-speed communication so critical in a cluster?
Well, it all comes down to efficiency, right?
Okay.
In a large cluster, you have multiple GPUs working together on a single task.
Right.
And they need to constantly exchange information.
Yeah.
And any delays in communication can really slow down the entire process. Right. So InfiniBand is designed specifically for high-performance computing.
Okay.
With incredibly low latency and high bandwidth, it's like upgrading from dial-up to fiber optic internet.
Oh, okay. So it's not just about like raw speed. It's
Yeah.
about removing those bottlenecks.
Right.
And making sure that data flows freely
Yeah.
between all the components of the cluster.
Exactly.
But I'm curious about this director switch thing
Yeah.
Lambda Labs mentions.
Yeah.
What are those, and why do they call them the final boss of networking?
So director switches are like the heavy hitters of the networking world,
Okay.
right? Imagine a massive switch that connects all the other switches in your cluster.
Uh-huh.
Instead of using cables, they use something called a backplane, which is like a superhighway for data within the switch itself.
Oh, wow.
To handle that immense traffic of a large cluster, you need a director switch that can provide what's called non-blocking bandwidth,
Okay.
right? That means no data gets stuck in traffic, ensuring maximum performance.
Okay, so director switches are like the ultimate traffic controllers, keeping everything moving smoothly,
Exactly.
even in the most demanding clusters.
Yeah.
This is starting to feel like we're building a city here, not just a computer system.
It's a great analogy.
Yeah.
And just like a city needs a reliable transportation system, a cluster needs a robust network to function efficiently.
Totally.
But networking is only one piece of the puzzle.
Right.
Another critical aspect is storage.
Right. We can't forget about the data itself.
Yeah.
What are the key considerations when it comes to like storage in a cluster environment? Is it just about having enough hard drives?
No, it's definitely more than just throwing a bunch of hard drives together.
Okay.
You need to think about capacity, performance, and availability.
Right.
And they highlight both open source and proprietary storage options, each with its own set of pros and cons.
So choosing the right storage solution is kind of like picking the right foundation for your city. It needs to be strong, reliable, and able to support the weight of all those buildings.
Totally.
Or, in our case, the data.
Exactly. And just as a city needs a power grid to keep the lights on, a cluster needs a robust power system
Right.
to keep those servers and GPUs humming.
Okay. Power management.
Yeah.
That's something I've always found a bit intimidating.
Sure.
It's not just plugging everything into a wall socket, right?
You're right. It can get pretty complex. And Lambda Labs dives into the world of single-phase and three-phase power systems,
Okay.
which are like the electrical equivalents of those single-lane roads and superhighways we talked about earlier.
Okay. All right. Break it down for me.
Okay.
I'm all ears.
So single-phase power is what you typically find in your home, right?
Yeah.
It's perfectly adequate for everyday use. But for large-scale computing, where you're dealing with like rows upon rows of power-hungry servers,
Yeah.
you need something more robust.
Right. Right.
And that's where three-phase power comes in. It delivers more power using the same amount of copper wire, making it much more efficient for those high-demand environments.
So it's all about delivering that power efficiently and safely
Yeah.
to all those like components.
Yeah.
But how do we like actually calculate the power needs for a cluster? Is there like some kind of formula?
There is, and it's not as scary as it might sound.
Okay.
They provide the formula for calculating power in three-phase systems.
Mm-hmm.
It involves voltage, current, and something called a regulatory decelerating factor.
Hold on. A decelerating factor.
Yeah.
What's that all about?
So think of it as like a safety measure, right?
Right.
It basically ensures that the power system isn't overloaded
Right.
and has some room to breathe.
Yeah.
The formula takes this into account by deberating the maximum power capacity of the system by a certain percentage, usually around 80%.
So it's like building a bridge that can handle like way more weight than it's ever likely to encounter.
Yeah, biggie.
Better to be safe than sorry, right? But I'm a very visual learner, so can we see how this actually plays out in like the real world?
Absolutely.
Yeah.
They break down the power specifications of a specific PDU,
Okay.
which stands for power distribution unit.
Right.
It's like a power strip on steroids,
Okay.
right? Designed to handle the high power demands
Right.
of a cluster.
Okay.
And they show how the formula and decelerating factor are used to determine the actual power capacity of the unit.
Gotcha.
So it's a great way to see the theory put into practice.
Okay, I'm starting to get a handle on this. And I love that they even show like pictures of those specialized plugs used in these high power systems.
Absolutely.
It's fascinating to see those physical manifestations of these like sometimes abstract concepts.
It is.
So we've covered networking, storage, power management. We're really building up this city of ours like brick by brick.
That's right.
What's next on our construction checklist?
Well, with all this knowledge in hand, you now face the final boss. The decision between building your own on-premise data center or opting for co-location.
Right, that big decision we touched on earlier.
Yeah.
Now it's decision time.
Yep.
What are the key factors to consider at this stage?
They reiterate those core considerations:
Yeah.
cost, control, security, expertise, and scalability.
Right.
It's really a balancing act, weighing the pros and cons of each approach based on your specific needs and resources.
Yeah.
They have a really comprehensive clustering guide on YouTube for a deeper dive into the nuances of each option.
Okay.
But ultimately, it comes down to what makes the most sense for your organization and its goals.
Okay, so there's no like easy answer.
Right.
But with Lambda Labs guidance, we at least have like the tools and the knowledge to make an informed choice.
You did.
This entire journey has been incredible.
Thanks.
We've gone from like those humble single workstations to planning out like these massive clusters and grappling with like power grids. It's like we've climbed this mountain of knowledge.
We have.
And now we're standing at the summit, like taking in this vast, incredible view.
It's a beautiful view.
Yeah.
And just like any mountain climber, you need the right gear and preparation to succeed, right? And this Playbook has given us that essential map and compass for navigating the world of ML infrastructure.
I love that.
But there's one final and perhaps most important question to consider.
Okay, lay it on me. What's that final question?
What are you going to build? Now that you know what you're going to build, you have to figure out where you're going to build it.
Right. Because we talked about like that core decision, cloud versus on-prem.
Exactly. And like we said before, there's no right answer.
Yeah.
It really depends on your specific needs. But let's say you've decided on the on-prem route and you're ready to start building your own cluster. You're going to need more than just a bunch of servers and GPUs thrown together.
Right, because like at this scale, it's basically a mini data center.
Yeah, it really is. And the Playbook emphasizes the importance of like a holistic approach to cluster design.
Okay, so what are the key considerations here? Where do we even begin?
Well, they break it down into several key areas: network, storage, power, and cooling.
Okay, so let's start with the network, because we talked about how critical high-speed communication is, especially when you have multiple GPUs working together.
Absolutely. And the Playbook goes into detail about the different networking technologies you might encounter as you scale up your cluster.
Okay, so what kind of like options are we talking about here?
Well, we already touched on Ethernet and InfiniBand.
Right.
But it's not just about the raw bandwidth.
Okay.
You also need to think about things like latency, the time it takes for data to travel between different points in the network, and message rate, how many messages can be sent per second.
So it's kind of like choosing the right roads for your city.
Yeah, exactly.
You need to make sure that the traffic can flow smoothly.
Totally. And that's where network topology comes into play.
Okay, topology, that sounds a little complex. Can you break that down for me?
Yeah, so topology refers to the way that different components in the network are connected.
Okay.
And there are a few common topologies you'll see in cluster environments, like tree, fat tree, and torus.
Okay, so different ways of like connecting the roads in our city.
Exactly. And each topology has its own pros and cons in terms of cost, performance, and scalability.
So choosing the right topology is all about finding that sweet spot based on
Yeah.
your specific needs and budget?
Exactly. But no matter which topology you choose, you're going to need switches to connect all those servers and GPUs together.
Right. And we talked about director switches as being like the heavy hitters.
Yeah, big guys.
Yeah, so what are some other like key things to keep in mind when it comes to like selecting and configuring switches for a cluster?
Well, one thing they emphasize is the importance of non-blocking bandwidth.
Right, making sure that nothing gets stuck in traffic.
Exactly. And that means choosing switches that have enough capacity to handle the maximum amount of data that might be flowing through the network at any given time.
Okay, so no traffic jams
No traffic jams.
in our data city.
Exactly. You also need to think about things like port density, the number of ports on each switch, and features like quality of service, which lets you prioritize certain types of traffic over others.
Okay, so it's not just about picking the biggest, fastest switches. It's about understanding the nuances
Right.
of how they're configured and how they work together.
Totally. And the playbook goes into detail about all of this.
Okay, that's good to know because it sounds like networking can get pretty complex when you're
It can.
building out a cluster.
It can.
But once we've got our network humming along,
Yeah,
we need somewhere to store all that data.
absolutely. And that's where storage comes in.
So what are the like main things to consider when it comes to storage in a cluster environment?
Well, they break it down into three key factors: capacity, performance, and reliability.
Okay, capacity, that's pretty straightforward, right? Just how much data you need to store.
Yeah, but you need to think about not just your current needs, but also your future needs, right? How much data are you going to be generating in the coming months or years?
Right. So plan for growth.
Always plan for growth. Now performance. That's all about how quickly you can access and process your data.
Okay. So this is like the speed limit on those roads in our city.
Exactly. And the faster you can move data around, the faster your models can train.
Right. So we need like a high performance storage solution. But what about reliability?
Yeah, reliability is critical because you can't afford to lose your data.
Right, right. Because that would be like, I don't know, a natural disaster wiping out our city.
Yeah, it'd be catastrophic. So you need to make sure your storage system is redundant, meaning there are multiple copies of your data stored in different locations.
So if one part of the system fails,
Yeah.
you don't lose everything.
Exactly. And they discuss various strategies for achieving redundancy, like RAID configurations and distributed file systems.
Okay, so we've got our network, we've got our storage, but all of this hardware needs power, right?
Lots of power, and that's where power management comes in.
Okay, so we're talking about like more than just plugging everything into a wall socket, right?
Oh, yeah. This is where things can get really interesting.
Okay, so what kind of like power systems are we dealing with when we're talking about clusters?
Well, we already touched on single-phase and three-phase power.
Right.
But you also need to think about things like power distribution units or PDUs.
Okay, the power strips on steroids?
Exactly. And uninterruptible power supplies or UPSs.
So those are like backup generators for our city, right?
Yeah, they provide power in case the main power source goes out, preventing any data loss or downtime.
And I imagine cooling is also a major consideration.
Yeah, absolutely. Right.
Especially with all those power-hungry servers and GPUs generating heat.
You need to make sure your cluster has adequate cooling to prevent overheating and ensure optimal performance.
Right, because if our city gets too hot, things start to break down.
Exactly. And they discuss different cooling options like air conditioning, liquid cooling, and even immersion cooling.
Immersion cooling, that sounds intense. What's that all about?
Well, it's basically submerging the servers in a special non-conductive liquid,
Whoa.
which helps to dissipate heat much more efficiently than air.
Okay, so it's like instead of using fans to blow air,
Right.
we're dunking the whole thing in liquid.
Pretty much, it's a very effective way to cool high-density clusters.
So it's clear that building a cluster involves a lot more than just like assembling the hardware.
Total.
It's about understanding all these interconnected systems and making sure they all work together seamlessly.
And this is where the playbook really shines.
Okay.
It provides a ton of practical advice on how to design, build, and manage your own cluster.
So even if you're not planning to build a massive data center anytime soon,
Right.
this deep dive has given us a much better understanding of the complexities involved.
Absolutely. It's about appreciating the intricate infrastructure that powers those amazing AI breakthroughs we hear about every day.
Right, because behind every impressive model,
Yeah.
there's a whole lot of engineering going on behind the scenes.
Absolutely. And it's fascinating to see how these different systems all come together.
It really is. It's like peeking behind the curtain and
Yeah,
seeing how the magic happens.
exactly. What are you going to build?
It's funny you should ask that because, like, this whole time we've been talking about the technical side, right?
Right.
Like, all the nuts and
The
bolts.
hardware, the
It's
software.
the considerations.
Yeah.
But you're right. Like, it all comes down to, like, what are you actually going to do with this?
Exactly. Like, what's the problem you're trying to solve?
Right, because it's one thing to have the tools and the knowledge.
Totally. It's a whole other thing to actually apply it.
To have that vision.
Yeah.
And to, like, know what you want to create.
And I think that's what makes Lambda Labs focus on starting small so powerful. Right. Because you don't need to be a Google or a Facebook to make a real impact in this field.
And that 40% of folks still training on premise.
Yeah.
That really stuck with me. It means that, like, innovation isn't limited to those with, like, the biggest budgets.
Totally. Like, anyone with a good idea and a decent computer can get started.
And the playbook, it's not just a technical how-to, right?
Right.
It's almost like a philosophical guide
Right.
to, like, empowering anyone with, like, the curiosity to dive into ML
Totally.
and see what they can create.
Exactly. It's about that spirit of experimentation.
So to our listener out there who's been with us on this climb, absorbing all this information, what problem are you going to tackle?
Yeah, like, what's the breakthrough that your infrastructure is going to enable?
Because we've covered the building blocks, the decision points,
The different paths you could take.
wait, but the blueprint is still yours to draw.
Absolutely, and that's what makes this field so exciting.
Yeah.
It's not just about following a set of instructions. It's about creativity.
Yeah. Yeah, maybe you're inspired to, like, optimize a model for a specific task, something that, like, no one's quite cracked yet.
Yeah, or maybe you're driven to, like, democratize access to these tools.
Right.
Make them easier for others to use.
Yeah, this deep dive has been about more than just, like, servers and switches, hasn't it? It's about empowering that drive,
That passion.
to build,
To contribute.
to contribute. Yeah, and who knows, maybe someday we'll be deep diving into the playbook you wrote.
I love it.
Based on, like, the foundation.
Based on everything we've talked about today.
Yeah, we've explored today. That's an inspiring thought to end on.
It is.
To our listener, keep that curiosity burning, keep experimenting, and keep pushing the boundaries of what's possible in machine learning. Until next time, happy building.